tomorrow this time, we're going to leave Amy a message. And the message is, we're so glad you're gone. Don't come back tomorrow. Here's your tip. No, that's a bad tip. Your supposed friend Aubrey says, no. Aubrey says, quit being grumpy. Okay, now let's learn. Okay. So at the top of this page, oh, let's back up. So we have reviewed linear equations, exponential equations. We have learned about recursive formulas and explicit formulas. We're now going to move on to what are called sequences, which are strikingly similar to linear and exponential. Let me give you an example of a sequence. The list of numbers 1, 2, 3, 4, 5, and going on. Okay. Now this sequence might go forever. It might stop. We don't know. Well, this one actually goes forever, but it can stop. Let me give you another one. Okay. That first list can be generated using a linear equation. It has a common first difference. That second set can be generated using an exponential equation. It has a common ratio of 2. Okay? So if you have a list of numbers that follows a linear pattern, we call that an arithmetic sequence. And yes, arithmetic is spelled exactly like arithmetic, but for some reason we say arithmetic. Don't know why. Go talk to the people who invented it. If a sequence is is exponential, we call it geometric. So you may have watched a movie at one time where they said the growth of the pimples on her face is exponential. Something like that. Well, if you watch a science fiction show, they might say the growth is geometric, which is exactly the same thing. Who knows? We don't know why. So, sequences, linear means arithmetic, and geometric means exponential. Okay? There also is another difference between functions and sequences, and that is a really annoying difference that's going to plague you, and you're just going to have to get used to it. Okay, back to this. So what you have here are 4 sequences. Okay, down here it asks, and these are out of order, sorry. What is the common difference for each sequence? What's the first one? +3 for B, -5 for C, +2.2 for D, 4/8, also known as 1/2. Okay? Now, a lot of times you'll be asked to continue a sequence. So it says find the next 3 terms and the previous 3 terms in the following sequences. So if we were to follow that sequence forward, what would it be? So 11, 14, 17. If I were to follow it backwards, what would it be? -1, -4, -7. Okay? So go ahead and find the next 3 terms and the previous 3 terms in each of those sequences. I'm going to pause the video. So look down at the next question. If I knew that a particular sequence had a common difference D, how would I calculate the nth term? And we're going to write this in its recursive form. Okay? So if I wanted to know what a sub n was, and I knew that the common difference was D, how would I calculate a sub n? You would take a sub n minus 1 plus D. That looks really familiar, right? We've been working on that for the last few days. So now, consider the arithmetic sequence 100, 103, and 106. What are the similarities and differences to the sequence? Ooh, that's supposed to be to sequence in A. Sorry. I changed some things and that one didn't get updated. So how are they similar? So they both use a sub n equals a sub n minus 1 plus 3, right? This piece is the same for A and for this sequence. How do they differ? The starting number is different. So if all you knew was this, could you write out a sequence? You couldn't, because you don't know where to begin. And you might say it doesn't matter where you begin, but it does, because if you begin at 1, you're going to have a totally different list of numbers than if you begin at 2. Right? You could have 1, 4, 7, or you could have 2, 5, 8. And none of the numbers in either sequence would be the same. Okay. So we're going to write recursive formulas for all of these. But the trick is, in sequences, we always start with a sub 1. In our recursive formulas that we've been dealing with up to this point, what did we begin with? We started with y sub 0 or a sub 0. But sequences don't work that way. So when we dealt with those problems where time began at 0, we had to use a sub 0 equals a sub n plus, or equals a sub n minus 1 plus whatever. But now, these are not tied to a story, and sequences always start with 1. And that's going to cause problems here in a second. Okay? So we know a sub 1 is 2, a sub 2 is 5, a sub 3 is 8, and so on. Which means the first term is 2, second term is 5, and third term is 8. So let's write recursive formulas for each of those problems in A through D. So what would A look like? So we state the beginning, a sub 1 equals 2. And then a sub n equals a sub n minus 1. And our common difference is 3. So go ahead and write out the recursive formulas for A through D and the rest of those. So your recursive formulas should look just like those. But there's a limitation in recursive formulas that we've already talked about. For problem number 1, that should say problem A, oops. If I wanted to know the 50th term of the A sub 50, do you really want to write out all of those and figure out what it is? I think not. So how can you find the common difference of an arithmetic sequence? I can't read the rest of that. Sequence the first term and the term placement in some way to find the value. How would we figure out A sub 50? We would use the explicit formula. Okay? So what is the explicit formula? So let's do y equals 3x plus 2. And if you plug in 50, you get 150. But we've overlooked something. You broke something. Let's consider our sequence in two different ways. So this is n and a sub n. We already know when n is 1, a sub n is 2. When n is 2, a sub n is 5. And when n is 3, a sub n is 8. So let's use this formula to calculate x's and y's. Well, if I plug in 1, what do I get? 5. If I plug in 2, what do I get? 8. If I plug in 3, I get 11. Those don't match. Right, they're close. This matches that, and this matches that. How can you explain that? No, you got it backward. 49 isn't going to work either. So Braden says plug in 51 or 49 and one of those two will work, but they won't. What's the trouble? Right. So in our slope-intercept form, this is my slope, my change per year, which is correct. And this number is, that's the y-intercept, which is equivalent to a sub 0. So I used a sub 1 instead of a sub 0. Well, I don't know a sub 0. They didn't tell me. So how do I calculate a sub 0? You take one common difference away from a sub 1. So a sub 1 is 2, which means a sub 0 is negative 1. So if I subtract 1 here, now they match. If I plug 1 in there, do I get 2? Yes. If I plug 2 in, do I get 5? Yes. So the trouble with starting with a sub 1 is that your explicit formula is going to require a value that's not given. You have to calculate a sub 0. And because this is sequences, and sequences build from the beginning on, we kind of change how our formula looks. So an explicit formula, so down here, an explicit formula is going to be in the form a sub n equals a sub 0 plus the common difference times n. That looks really familiar, right? Have you seen that formula before? Yes, no? All it is this, right? To find any term, I take the beginning term, which is the y-intercept, and I add the common difference n times. So I'm taking the slope and timesing it by x and adding it to the original value. So this is really just the slope-intercept equation written in a different form. So you can actually write an a sub n formula that's explicit, that looks like this. You can also write an a sub n formula that is recursive. And switching between the two is a little problematic. And the trick you need to remember is the explicit formula has to include a sub 0. There's actually another way to do it where it doesn't include a sub 0, and I'll show that to you in a second, but it's kind of a waste of your time. So, okay. And I warn you, Tom wrote this worksheet, and I edited it as best as I could, but a little bit of Tom is still shining through. So now put on your big people math pants and write an explicit equation that will help us find an arithmetic sequence. So we already know a sub n equals negative 1 plus 3 times n. That's the explicit formula for A. What will the explicit formula for B look like? And that's, we're going to write it in the sequence version. So B sub n equals, well, what is B sub 1? 15. So if I go back one common difference, that would put me at 20. So 20 plus, my common difference is 5n. Oh, negative 5, thank you. Glad somebody's paying attention. So negative 5n. What would my formula for C look like? C sub n equals, so my C sub 1 is 2.7. If I backtrack to C sub 0, what do I get? 0.5 plus my common difference, 2.2n. Okay? What is D sub n going to look like? So I take negative 3/8, and I have to backtrack how far? I got to go back 1/2, which is 4/8. So if I'm at negative 3/8 and I go back 4/8, that would be negative 7/8 plus 1/2 n. That would be the formula. Okay, so it says find each value. What does a sub 101 really mean? What is that saying? That's the 101st term. What is the value of the 101st term? How do you find that? Well, you could use the recursive formula and plus 3, plus 3, plus 3, but that's a waste of time. We're going to plug n equals 101 in here. Okay? What about a sub negative 5? What is that asking for? That would be 5 terms before negative 1, or sorry, 5 terms before, anyway. So I'm going to plug negative 5 in there. Got it? Okay, this is more difficult. If I know that a sub n equals 104, what is the value of n? What is that asking? Yeah, and we don't have that equation anymore. So, but what is this asking for? What does this really mean? How many terms do you have to do in order to get to 104? Well, let's do one of those. So I'm going to plug 104 where? I'm going to plug it in to a sub n. So 104 equals negative 1 plus 3n add 1. So 105 equals 3n, divide by 3. That's going to be 35. Okay? So that's not too bad. And then you get to this problem. If the 11th, so here we stop using the A, B, C, D. We're going on to sequences that we have yet to define. If the 11th term's value in an arithmetic sequence was 27, with a common difference of 5, what was the original value? What is that asking for? Not a sub 0, a sub 1. So this is saying if you know a sub 11 is 27 and it's going up by 5s, what was a sub 1? The next question, if the first term is 2.3 and the common difference is 1.5, what term in the sequence will have 24.8 as its value? What is that asking for? And what variable is the term number? N. So this one wants to know what does n equal. This one wants to know what does a sub 1 equal. Okay? I'm going to let you work on those, and then we'll record again in a minute. Let's talk about a couple of these. How about a sub n equals 198? What did you get? 66.3. Repeating, right? Is that the answer? What is the answer? No, you can't. So before we were making calculations of particular watermelons or something. You can't have a whole watermelon. But this one says which term gives me 198? What value for n gives me 198? There isn't one, because n has to be a natural number, right? N is either 1 or 2 or 3 or 4 or 5. So can you have 66 and 1/3 terms? No, remember this is a dotted line strictly. So once you get to 66, then you get to 67, nothing happens in the middle. So that one has no solution. There is no n value that works. Okay. So let's talk about the next one. This is a really good problem. So if the 11th term's value in an arithmetic sequence was 27 with a common difference of 5, what would be the first term? How would you calculate that? There are a couple ways to do it. So let me write this out. A sub 11 equals 27, and I know that D is 5, and I'm looking for A sub 1. Well, I could write it out in the formula. A sub n equals A sub 0 plus D times n. What do I know in that formula? I know n, I know D. I know A sub n, which is A sub 11, which is 27. So this is 27 equals A sub 0 plus 5 times 11. So the easy way to solve that is just subtract 55 and you get negative 28. Alexa, what do you think? Why is that not right? That tells me A sub 0. Am I looking for A sub 0? No, I'm looking for A sub 1. So I could take this and add, not 11, 5. Okay, I think you guys understood what's going on. So I could add 5 to this. How could I change my equation to make it work? Well, what part of this equation is making this not work like I want it to? Right, I could make this 10. If I made that 10, then this would become A sub 1. So wait a minute. You're telling me that A sub n equals A sub 0 plus 5 times n is exactly the same thing as A sub n equals A sub 1 plus 5 times n minus 1. Is that true? So if I take the original term and I do 5 times n, will I get A sub n? Yes, that's the formula we've had. If I jump and I take the first term and I times it by 5, I add it to 5 times n minus 1, why is that exactly the same thing? Well, how do you get from here to here? You add 1, right? You add 1 what? 1 n. So whether that n is here or here, this is still a total of n n's. Do I have n n's here? Yeah, I have n minus 1 here, and I have 1 there, and n minus 1 plus 1 is n. So you could continue that. A sub n is equal to A sub 2 plus 5 times n minus 2. And you could make an infinite number of formulas like that. So let's skip the next one and go to the back. If 219 is the 21st term and the first term was negative 1, what is the common difference? Well, if I use the formula A sub n equals A sub 0 plus D times n, is that going to help me out at all? Do I know A sub n? Yes, it's 219. Do I know A sub 0? No. Do I know D? No. Do I know n? 21. So that would leave me with 2 variables. That's a problem. But I could rewrite the formula. A sub n equals A sub 1 plus D times n minus 1. Do I know A sub n? It's 219. Do I know A sub 1? Negative 1. Do I know D? No. Do I know n minus 1? It's 20. And then I could solve. Or you could do what I assume Alexa did. How did you solve that? So she knows the sequence starts at -1, and then it ends out here at 219. So how much has the sequence gained? 220. Then what did you do? Well, let's back up a little bit. Then she said, this is n equals 1, and this is n equals 21. So how many n's have I implemented? 20. So I did 20 n's over the course of 220 numbers. So she divided those and got 11. Well, guess what? A sub n equals a sub 1 plus d times n minus 1. This is 219 equals -1 plus 20d. If you add 1, you're going to get 220, and divide by 20, you're going to get 11. So you can either think it out logically and figure it out like Alexa did, which is the way that I would have done it, or if you're a formula person, you can adapt the a sub n formula to match whatever you wanted. So what if I told you a sub n, and I told you a sub 5, what would you multiply d by? N minus 5. So if I tell you the 5th term is a certain value, and the 50th term is a certain value, what's the common difference? Well, you can plug in the 5th term there, and you can subtract off 5 n's from this term. So this formula is super adaptable, or you can just do it logically, like Alexa did. Okay? So I want you to get down to, for your assignment tonight, I want you to get down to here. Okay? And I don't have answers, I apologize. This is still a work in progress, so we don't have answers yet. Oh, did you guys want to talk about, what did you get for the last one on the first page? So a sub 1 is 2.3, d is 1.5. So what does n equal when a sub n equals 24.8? How do you figure that out? We can just plug it into a sub n equals a sub 0 plus d times n, but I'm missing something. I don't have a sub 0. I have a sub 1, so either you put a sub 1 here and you subtract 1 from n, or how can I calculate a sub 0? Well, I know a sub 1, and I know d, so 2.3 minus 1.5 is 0.8. So you either put 0.8 there and then calculate n, or you do it the other way, which is a little creepy because you end up with an n minus 1. So however you decide to get it, what answer do you get? Is it 11? Or is that one 16? That one's 16. So however you do that, the answer should be 16. Okay. Good luck.